Hey everyone, it's Ed from Online, as some of you have been calling me. I'm back again with another video, and in this one I want to cover how to program a Mecanum robot. Now, this isn't harder than a typical tank drive or arcade drive robot, but there are more motors, there are more wires, there's more lines of code, and that just means there are more places where a single mistake can happen and cause things to not quite work. So in this video, I'm going to walk through how to program it for both Teleop and Auto, and hopefully if you follow along, you'll be able to get your robot up and running. So with that said, let's get into it. So here I have an example of Mecanum robots. Now the way this works is we have 1, 2, 3, 4 motors on the robots. And these have to turn in very particular ways to allow the robot to drive forward, backwards, left, right, and to rotate clockwise and counterclockwise. I'm going to call this the front of the robot. This will be the back. That means this motor here is the front right motor. Down here is the back right motor. This motor here will be the front left motor, and the motor hidden down there will be the back left motor. It's very important that when you configure your robot that you label each motor correctly on your control hub so that when we tell the front left motor to drive, it's the actual motor driving. If we don't get this right, we're going to have a bad time. And what I'm going to do is I'm going to create a simple program to talk to one motor at a time and make sure that the motor I want to talk to is the one that actually responds, and that when I give it a positive number, the wheel turns such that the robot drives forward. This will make sure that 1, all my configuration is correct, and 2, we identify which motors, if any, need to be inverted.
Now, as always, when we're programming our robot, the first thing we do is make sure we're connected over Wi-Fi, and then we open up our favorite web browser and go to 192.168.43.1:8080. And when we go there, we have the web interface for the robot. This lets us test the robot without having an actual USB connection to it. I'll go ahead and go to blocks and create new op mode. I'll go ahead and call mine Mecanum Teleop, and I'll use basic op mode as our sample and click OK. And to start, I'm going to say every motor by default is going to be set to the forward direction. And what I'll do is, as I'm testing our motors, I'll invert the ones that are needed. So to do that, I'm going to go to DC motor, grab this reverse block, change this to my back left, forward, copy paste, copy paste, copy paste. And then the next thing I want to do is simply turn on one motor at a time. Let's go front left to start. Let's do front left to 0.25 power. We'll click save, and I'll go ahead and show you what that looks like on the robot.
All right, I'm going to make sure my code is selected here. Mecanum Teleop. I'll press init, and when I press start, I should see the left front wheel rotating this direction because that will take the robot forward. So I'll back up here, I'll press play, and indeed we do see that wheel turn forward.
So the front left was good. Next we'll take a look at the back left. So I'll change that there, press save, and head back over to the robot.
And this time, this is the back left wheel, so we should see this one spinning. I'll press init and press start. And we do see it spinning. However, it is not spinning in the correct direction. This direction takes the robot backwards. So we want it to spin the opposite way to push the robot forward.
So our back left wheel is incorrect. So what we should do is change this to reverse, and we'll click save, and let's try it again.
All right, we've reversed the direction of this back left motor. So when I hit init and start, we do see it turn the correct direction now. So this side looks good. We're going to look at the other side next.
Once again, to change the motor, instead of back left and front right to start, and save that. And let's take a look on the robot.
Okay, I'm on the right hand side of the robot this time. This is my front right wheel. So when we turn this on and run our code, it should be spinning this way. So I'll press init and start. And that wheel is spinning instead. So we wanted to turn this one, but that one is spinning. What that means is we have the front right motor labeled wrong. It's currently talking to the back right instead of the front right. So what I'm going to do is trace these wires, which come up to here, and it's these two wires right here. So what I'll do is I'll flip those around and rerun our code and make sure that this motor turns. Init, start. I now see this motor turning, so that's good. Our last and final step is to verify that this motor is correct and spins the right way.
So hopefully you caught on by now. We're going to change this to be the back right motor. We'll click save and test it again.
Okay, our last check. This motor should spin this way. Click init and start. Indeed, we see that is correct.
Great. So at this point, we verified that each motor is in the correct spot and is driving in the correct direction. Typically, you will have either your left side or your right side inverted. In this case, only one of my motors is inverted. The purpose of this is to make sure that we get all that correct before we do all the more complicated Mecanum drive math. Do not proceed with the next steps in this video if you haven't verified that each motor is in the correct spot and going in the correct direction. Now, when it comes to programming, one of my favorite phrases is steal from the best, invent the rest. Smarter people than me figured out the math for Mecanum driving, and I'm going to copy what they do and add my own little adjustments to it. So the site I want to point out to you is called Game Manual Zero, and they have a wonderful page for Mecanum. If I click on that link there, this whole page is devoted to how this drive system works, and all the math and how they build up their code. I'll go ahead and click on the blocks tab here, and that changes all these code examples to blocks. And I'm gonna scroll down until I see this robot-centric final sample code. This is the magic thing that we are going to copy. The first thing I'm gonna do is get my power block out of here. We don't need that anymore. And I wanna set up a few variables to take the inputs from my driver. So I'll call those forward, I'll call one side, and I'll call one turn. And for my forward direction, what I'll do is I'll grab this set block, put it just below this comment that says put loop blocks here. I'll change this to forward. And then we're going to grab a gamepad input, so that's under gamepad. Gamepad 1 is usually what I use for my driver. I'll grab the left stick Y. And when we push forward on that stick, we want the robot to go forward. Unfortunately, that stick gives us a negative value, so by multiplying by -1 in front here, when we push forward on that stick, we get a +1, and that'll make some of our math easier. I'll next set my side to side to be my gamepad 1 dot left stick X, and I'll set my turn to be gamepad 1 dot right stick X. Then for debugging, what I love to do is go to Utilities, Telemetry, add some telemetry here. What do I want to add? I'll add forward and grab a variable and say, go ahead and print out the forward speed onto the driver station. That makes debugging code a little easier if there are any problems. I'll do the same for side to side and for the turn. We're going to create a new variable called denominator. I'm going to shorten that to denom here. We'll grab another set block. We're going to go to math, grab the sum block here, the sum of list, and we're going to change that to, instead of sum, be the max of this list. This list will be created by going to list, create an empty list, click the gear here, it opens up the configuration here. We'll remove one item here. We see our block updates. This will be a list of math, number, 1, and another summation. That's here under math. Create a sum of a list of what? A list of our 3 inputs here. We'll go to math, grab absolute, grab variable. Let's start with forward. I'll copy paste, change this to side, change this to turn. What on earth is this doing? This is going to take our inputs and scale them to be between 0 and 1 when we do our math. This is needed so that all our motors behave nicely if we do something like push forward on the stick and push left on the other stick. Otherwise, the math will start computing values that are greater than 1 for our motors, and our motors only want values between 0 and 1. Now finally, we're actually going to start setting the values for the motors to turn. So I'm going to start with the front left. So I'll go to actuators, DC motor, grab a power block, change this to front left, and front left is going to be set to some math. I'll start by grabbing a divided block here, and we'll put the denominator on the right hand side here. Next we'll grab an addition block and a second addition block. I learned while doing this video that the nesting here is very important, so I'm always nesting these on the left hand side. I'll go to variables, I'll grab forward, I'll go to variables, I'll grab side, and variables, and I'll grab turn. So the front left is forward plus side plus turn divided by the denominator. And that's a lot of work, so instead of redragging all those blocks, this time I'll just duplicate the block and change this to back left. And the back left is going to be forward minus side plus turn. And then I'll duplicate this again. Our front right will be forward minus side minus turn. And I'll duplicate one more time. And our back right will be forward plus side minus turn. And that should be all our drive code. So I'll go ahead and save that, and we'll give it a test on the robot.
Okay, I'm over at my robot now, and I've got my controller plugged in as controller 1. So I'll press init and start. And I'm going to recommend you have the robot up on blocks or something. I've got a box underneath it so that if the robot doesn't behave as we expect, it doesn't drive off a table and start making expensive sounds. So with it up on blocks, I'll push forward on the left stick. And I see all my wheels rotate forward, which looks good. I'll now pull backwards on the stick. They all look backwards, so that's good. I'll push left. And I see they're counter-rotating. To be honest, I can never remember which direction it's supposed to be for left and right, but let's see. When I push right, it goes in the opposite direction, so it's probably good. And now I'll push counterclockwise, which is right stick X. And I'll go clockwise, which is right stick the opposite way. That all looks good. And I'm not pushing these at 100% because I like testing at low speeds. I'll get the robot on the ground, and let's try forward, backwards, left, right, clockwise, counterclockwise. Forward, good. Backwards, good. Left, good. Right, good. Counterclockwise, good. Clockwise, good. Okay, this all looks good.
The next thing that I like to do with Teleop code is the ability to add some kind of like turbo and precision mode. I find this lets me drive the robot in a normally controlled manner, but then add a bit of speed when I need, and this is some customization that I really like to add. So what I'll do is create a new variable called drive factor, and I misspelled it, but that's fine. And what we'll do is go to logic, and I'll grab this if else, and I'll put it right here kind of above where I get my joystick inputs. And we'll say gamepad 1 dot left bumper, and what we'll do is we'll say if that button is pressed, set the drive factor to be, let's go 0.25. Copy paste that block. I'll copy paste this block. And if the right bumper has been pressed, then we'll change this to 1. Otherwise, what we'll do is change this to 0.5. So what this means, when we press the left bumper, drive factor will be at 25%. When we press the right bumper, our drive factor will be at 100%. And when we press neither of those, it'll be at 50%. What I then do is I take a math multiplication block and I multiply each of my inputs by drive factor. And this will give us a really easy turbo/precision mode buttons.
It helps if I plug the joystick in now, doesn't it, Ed? Good job. And I'll press forward on the stick. Backwards, left, right. Looks good. Now I'll press holding the left bumper, so this should be our precision mode. If I push all the way forward on the stick, you can see it drives significantly forward. You can see the difference between when I let go and hold the button. Next, we'll do the right trigger instead. So I'll hold that and press forward. See, it's much faster now. You can see the speed difference between releasing that button and holding that button. And that's pretty fun to drive, but it's also a very nice little touch to make this really customizable and controllable for your driver.
So that's going to complete our Teleop code. We now have a Mecanum drive that works. We know all the motors have been configured the correct way, and we're going to use this as the start for our autonomous code. So what I'll do is I'll click Save Op Mode. We see successfully saved. I'll go back to my blocks, and I'll click this checkbox for Mecanum Teleop, and I'm going to say copy that. We'll change it to Mecanum Auto. Click OK. And we now see we have a new file. So I'll click on Mecanum Auto. The very first thing we'll do is change this from Teleop to Autonomous. And then I recommend you select which Teleop you want to run when this is done. So next, because we have all of this set up, we don't have to redo any of the math down here, which is good. However, we can't actually get joystick values from the driver during autonomous because the robot has to run on its own. So we need to basically pull out all of that stuff. So what I'll do is I'll grab everything in this while block and pull it out to the side here. And then we'll add back the things we need. So we can't get anything with driver inputs, so anything that has a driver input I will delete. So that's going to be our turbo, our forward, our side, our turn. And I'm going to go ahead and delete the telemetry because I don't think we need that. And I'll grab all of this, which contains our Mecanum math. I'll pull that aside. And finally delete that while block. So what we're going to do next is put this bit of code into a block called a function. So we go into functions, we can see there's two options here. We'll grab the top option here. And I'll call this a timed drive. And we're going to take all of this and drop it inside there. And next what we'll do is we'll click the settings icon here. And we're going to make a few inputs. So we're going to create an input called forward. And I'll click that and drag it in here. Next we'll create one called side. We'll take that and drag it in there. We'll do another one called turn. And the final one we'll create is going to be called time seconds. Click that and put it in there. And next what we're going to do is we're going to go to functions. We see we have new blocks down here and we have this timed drive block. So I'll drag that into our program here. And every time you see this block, it is going to run our function, which is all of this bit of code. Cool part is we can supply how much we want it to go forward, how much we want it to go side to side, how much to turn, and for how long to do that. And we can take this whole bit of code, copy paste it as many times as we want. So we could go forward and then side to side and then turn, and we can play with all this to get the robot to drive where we want it to. Now before we can use this, we have to do a few more things over here. If I say I want to go forward for 1 second, this will compute all the motor values and it'll assign the motor values, no problem. The motors will turn on, and then they're going to keep going, because we actually have to use this time seconds. To do that, I'm going to go to linear op mode, call time sleep, go to math, grab a multiply block. What are we going to multiply? We're going to multiply time seconds by 1000. And this will make sure that when we enter a 1 here, instead of sleeping for 1 millisecond, which is 1,000th of a second, it'll sleep for 1 second instead. Then we need to say for each of our motors that we're controlling, go ahead and turn them off after we've slept for a bit. So that's our front left, our back left, our front right, and our back right. One final thing I like to do in setup is to say actuators, DC motor. This zero behavior break block, we're going to drag that in there. And we're going to say all of these motors, when they're not doing anything, they are going to be in what's called brake mode. If you've ever driven a car or go-kart, this is kind of like the difference between letting your foot off the gas and actually applying the brake. I've found for autonomous, these motors typically like to be in brake mode, and that makes the driving of your robot a little bit more consistent. And for now, let's get rid of all of this. So our only instruction here will be drive forward at 30% speed for 1 second. Let's go take a look at that on the robot.
Now, when running our autonomous, it's very important we always start at the same location on the field. So what I've done is I've used kind of the lines in my carpet to line up my robot, and I'll grab my driver hub here on the left-hand side. I'll select my auto. You see at the bottom here, it's automatically going to select my Teleop. I'll click init, and then let's click start. Okay, we saw the robot drive forward, and then the autonomous ended. Let's add another step. Let's say after this, let's turn 90 degrees this way.
So now if we want to add another drive step, all we have to do is copy this timed with drive block and just change these values to change how we want the robot to drive. So let's say after driving forward, let's make it turn. Let's go 40%. Why not? And let's see what that gets us.
Okay, I've got my driver hub again. I'll hit the drop down, Mecanum Auto Init, and start. Forward, turn. Looks pretty good. I needed to turn the opposite way, so we'll change that real quick. And it went slightly too far, so I think I'll change the time just a little bit.
Okay, to change the direction, we'll change this to a negative sign there. And let's go 0.8 seconds on the turn. And let's see, we've demonstrated forward, turn. Let's do a side to side next. So I'll copy paste my block. And let's go 0 for the turn. And let's go, let's say 0.3. I liked how fast that was. Let's go half the time. Let's go 0.5 seconds. And save, and we'll try that.
Hopefully you get the routine at this point. We've started our robot in the exact same spot. I select my auto from the drop-down, I press Init, and we press Start. Okay, I think that looks pretty good.
One final thing I'll share with you is a note on troubleshooting. Mecanum code can be a little tricky to troubleshoot if you've followed all those steps and it's still not working. So what I'm going to recommend is if you've done all of this, you've confirmed your motors are set up correct, you've confirmed they're moving in the correct direction, you've confirmed they're inverted correctly or not inverted as the case may be, and it's still just not driving in the directions it should, and you think something's wrong with either the math or the code here, my suggestion is to pull out everything except one motor. Save your code, run it, push forward on the stick, make sure that one motor that you still have active moves forward, and then pull back on the stick, make sure it moves backwards, and then push left on the stick and make sure it moves in the direction that moves the robot to the left. If you don't know what those are, head back over to Game Manual 0 and make sure that, let's say we're doing the front left motor, make sure that it's behaving correctly in each of these cases. Once you've done that, go ahead and add your second motor back in and repeat everything. You may find that you need to invert one of these signs, either this one or this one. Iterating that a few times will usually allow you to figure out what sign is wrong and make the correction if needed.
Alright, so as always, I hope you found this useful. I hope you're able to use this to either set up your robot and get it up and running, or maybe troubleshoot your robot, or even just to learn. I think this is really cool stuff. I'll have links to images and code resources in the usual places, and if there's anything you want to see me cover in the future, let me know. Till then, take care.